GitLab CI/CD, as the name already suggests, is a CI/CD platform. So let's start from the very beginning and define what is CI/CD and what does a CI/CD platform even do? And why do we even need this whole thing? Let's say you have a great idea about a cool application. You define its functionality, or in other words, what features it will have. Then you code it, you test it. Now that you have a tested application, you want to actually deploy it on a public server and let the users access it. For that, you build and package your application in some kind of executable form in order to run. You configure the server with all the needed stuff, like installing any tools that the application needs in order to run, and then deploy the application. And with that, you have launched. The users can start using your application. Now, that was the initial launch of the application, but the application development is not completed. If you see users like your application, you would want to make it even cooler and add new features, maybe optimize the performance by getting better servers or making your application even faster, and so on. So you still have a lot of things to do. And every time you improve your application, either the code itself or the server configuration, you want to make this improvement accessible to the end users immediately. So after the initial launch, you do multiple updates to your application. And to keep track of those updates, you version those changes. There are many ways to version application changes. You may choose the one with 3 version numbers, one for major changes or major releases, like you replaced a programming framework used for coding. You have another version for minor changes, like you added a new feature, and the third version for quick, small changes, like a small UI fix, for example. And you do that over and over again. You have the idea of an improvement, you code it, test it, build and package it, deploy it, and observe it after release to see, 1, are there any new improvement ideas, or second, are there any issues that need to be fixed? So you have a process of continuous delivery of changes, an endless cycle of improvements. And CI/CD is in the heart of this DevOps process and is a method to frequently deliver application changes to customers in an automated way. Now let's break this down further and understand what the CI and CD parts actually mean. And let's start with the CD part. Now, if we zoom in on the deployment part, we will see that we don't just deploy the built application directly to the end environment, often called production environment, from where it's accessible to the end users. Why? Because we aren't sure that the changes are safe and they won't break stuff. And for huge applications like Facebook, LinkedIn, with complex code and dependencies, any small change may actually affect the whole application. And you don't want a small code change to bring down the whole LinkedIn application for millions of users. We don't want to risk that. So we deploy the application in stages so that we can test the changes extensively before we really fully release it. So we deploy to the first stage, which is often called a development stage, which is very similar to the final production stage. And we test the changes there. We run some automated tests like unit tests and functional tests to see that the application functions properly. We may also run code analysis tests or lint tests, because in order to keep code maintainable, not only the code needs to work, but it should also be written properly in a clean way. If the tests fail here, we know that we shouldn't release those changes to the production, and we have some cleanup work to do. If everything works, we can deploy the changes to the next stage, which is often called either testing, staging, or pre-prod environment, which again should be as much identical as possible to the final production stage, because we don't want any surprises. We want to be sure that we have tested everything about the application in a realistic environment. Now we know the application functions and code is written properly because we ran those automated tests, but what about the application performance? Maybe the changes made the application slower, or it made it use more resources like CPU and RAM. So now we have heavy loads on the servers. We don't want the application to crash under this load. So we may want to do some performance tests on this pre-production environment. Now, if everything works on this stage as well, we can finally deploy to the end stage, which is often called production, with more confidence, knowing that we have tested all aspects of the application. So a common setup is to have a development, testing, and production stages. So that's the whole deployment process, where we streamline the deployment using automated testing all the way to the production. Now think about this. In many projects, automated testing is not 100% reliable because someone needs to write those tests as well. And often developers have a pressure to develop new features and not enough time to actually write those tests. Or the application logic may be so complex that writing automated tests in order to test every aspect of the application may be super difficult. Or it could be that management simply feels not confident automatically deploying to the production, and there should be someone, a human, who manually approves the final release step to production. So basically, it is very realistic that you don't have automated tests that you can 100% rely on, which means you can't automatically deploy all the way to the production without a human intervention in the process. In which case, you need some manual testing, where test engineers come in and manually test the application in addition to the automated tests. And this means you can streamline the deployment only to the non-production stages. So the pipeline will be automated until development or staging environments and will be then promoted manually to the production. And this has its own term, and it's called continuous delivery. Okay, so we saw the CD part of the CI/CD concept, which is either continuous delivery or continuous deployment. Now, what about the CI or continuous integration part? What is that about? For that, let's zoom in on the side where the pipeline actually starts. When a developer commits their code changes to a Git repository that triggers the pipeline. So you have the main branch. Developers are working on code in parallel, each of them having their own local copy of that code. So they make changes to the same code base locally. And changes of these developers need to be integrated or merged to that central shared code. So the first developer, let's call him Tom, checks in or adds their local changes that he's been working on for days to the main branch. Now the second developer, let's call her Kate, wants to also merge a bunch of her local changes. But now her local copy of the main branch is not the same as the remote main branch anymore because it has changes from Tom that she doesn't have yet locally. And on top of that, it could be that they both changed the same code, in which case she will actually get a conflict. Git will say, I'm sorry, but I don't know which changes to take. Tom has made the same changes as you have, so you should decide as developers how these should be merged. And she, of course, doesn't want to override the changes of Tom, so she walks over to Tom, they talk it out and decide how to merge the conflicting changes. Another problem is when you have lots of code changes that you work on for days or even weeks, you don't know how much you affected the application. Did you break any features, any existing logic? How do you find out whether you broke something in the application? Well, you test your changes by running automated tests. And of course, the bigger the changes, the more likely that something in the application breaks. So you may end up with a lot of failing tests because you broke some logic in the application. And other developers will then check out those broken changes, and you'll have to fix a bunch of issues and get all the tests green again. And these are just 2 developers. Imagine you had 10 developers or 50 all working on the same code in parallel, which is also a quite common use case. Imagine what kind of mess that would be. So to solve these issues of conflicting changes and testing code frequently, the rule is that everyone should merge or integrate their changes with the remote repository in small chunks and frequently. So the code changes get continuously integrated into the main branch, which means merged, so others can update their local state and then test it to make sure the changes didn't break anything in the application. And that's what the CI, or continuous integration, actually stands for. So with these two parts, where developers continuously integrate their small code changes to the repository, which then triggers the process of manual testing and deploying it to the development environment and all the way to the production, gives us the complete CI/CD pipeline, which is either streamlined and fully automated until the development stage or all the way to the production stage if you have enough proper automated tests for your application.